Again, I'm David Devore, avad3. So before we talk about network, got another little clip for you. Short, sweet, hilarious.
Because we've got tons of internet here for your attendees. We've just put in a whole bunch of wireless internet repeaters, phew, 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 all over the hotel, internet everywhere.
I see that.
All right. Internet, network. So the modern era has brought to us the computer, which is a super duper useful thing. And finally, the production industry is catching up. Manufacturers are realizing that having to touch things is annoying. We're all in front of computers anyway. Shows are covered with computers. Why can't we just control everything with a computer? And so to do that, they're starting to integrate more and more networking capabilities into basically everything. There's network-enabled soundboards. There's network-enabled speakers, network-enabled power amps, network-enabled comm systems, network-enabled video switchers, network-enabled projectors. Basically, if it was made in the last year or two, it most likely can be attached to a network and you can control it with a computer, which leads to some super flexible setups and some great control options for the technician. So we're going to talk about network, how it works, how it does things. We're going to talk about the global internet for a little while, and then we'll dive into specific networks. So there's two big terms. There's a WAN, W-A-N, or the Wide Area Network. That is what's most commonly referred to as the internet, because it is a wide area network, covers the whole earth. And then there's also a LAN, or a local area network. That would be the stuff that you're actually plugging your computer into. So if you've ever heard of layer 2 or layer 3 capable or stuff like that, these are the 7 layers of the OSI, which I don't remember what it stands for, but they are an organization that determines what happens on a network. So there are 7 layers to these. They basically sum down into the application layer, which is the top 3, can be kind of referred to as the application layer. The OSI in the 7-layer model splits them out into 3 different things. Then you have the transport layer, which is layer 4, and sometimes into layer 3, depending on what model you're looking at. The data layer, and then the physical layer. So we're going to go into those, and we're going to talk about the different protocols. Protocol is just a fancy word for a set of rules that a group has decided on to basically determine how things on a network interact with each other. So we're going to talk about those protocols. So in the application layer, that's kind of what do you want to do questions for the stuff. That's the application layer. What do you want to do? Then where are you going? That's kind of the transport layer. How do you get there? That's kind of the network layer. And then, how do you get there is the data layer, the physical layer. And then did you get there is in the data layer. So let's talk about the physical layer. That's layer 1. That is literally talking about physical things. It's not a joke. They're talking about cables, fiber cables. That's a fiber trunk line that Google uses to send Google Fiber to places. Fiber is light signals passed through glass. It's really neat. It's very high speed because it travels at the speed of light. Isn't that amazing? There's also Cat 5, Cat 6, Cat 5e, Cat 6e, so on and so forth. You've probably seen those cables. And then there's wireless, which is can travel over microwave signals or in the 2.4 gigahertz or the 5 gigahertz range. That's Wi-Fi, wireless internet. And then we have the data layer, layer 2. This is where the data is. So the most common protocol used on the data layer is called Ethernet. You've heard that before, referred to a cable. It's not actually an Ethernet cable. It is a cable carrying Ethernet data. Does that make sense? So Ethernet is the protocol that's the most common. It kind of rules the industry as far as that stuff goes. So it is a CSMA/CD, which stands for Carrier Sense Multi-Access Collision Detect. Basically, anything on the Ethernet network can send out information whenever it wants. But there are rules. So carrier sense means it can sense if it's on there. Multi-access means you can put a bunch of things on there and they can all play together. And then collision detect says if thing 1 is sending a message and thing 2 is sending a message simultaneously, they'll find out about it and then try again. So then thing 1 will send it and then thing 2 will send it. Collision detect. So how do you know if you're on the Ethernet layer? What is the Ethernet layer? How do you get there? So you need an address, right? Everything that is ever created that is designed to go onto an Ethernet network has its own address. It's called the Media Access Control, or MAC address. You ever heard of a MAC address?
Yes.
So it's commonly shown as like a 12-digit hex code. It's like 2C:3D:4F:55:69. Something ridiculous. So that's unique to literally every device that has ever been created. Has its own MAC address. Just think about that. That's ridiculous. And on top of that, your wireless receiver in a computer or any other device has a different MAC address than the hardware port. So if you plug a cable in, it's a different MAC address than if you connect to a Wi-Fi network. It's an absurd amount of addresses. So what happens on the Ethernet network is, so if thing 1 wants to talk to thing 2, it'll send a broadcast message, which is sent to every device. It's just a broadcast. It just yells out into the space, "Where's Bob?" Everyone hears this thing ask, "Where's Bob?" And then Bob replies and says, "I'm Bob. This is my address." And because on the broadcast address, thing 1 sent its address with the broadcast, it said, "Hey, where's Bob? BT Dubs. I'm at 126, Jones Street." Then Bob replies and says, "Hey, thing at 126 Jones Street. I'm Bob. I'm over here at 194 Adams Street." And then they can continue having their own private conversations by basically sending out information addressed specifically to Bob, not just to everyone. So how do you connect things to a network? With a switch. Not that kind of switch, this kind of switch. So here's the switch. Look familiar? The switch is that switch. So if you were around for the early days of the internet, you might have heard of a thing called a hub. It looks very similar to a switch. A hub is not a switch. Switches are actually really neat little devices. You may think that it's just passing data from here to here and then moving on about its life. It's actually making a table of everything that sends data through it. So if thing 1 sends a message, a broadcast message saying, "Where's Bob?" and it puts its address at the end of it, then the switch says, okay, thing 1 is at 126 Jones Street. I'll remember that. And 126 Jones Street is down my port number 1. And then Bob replies, and Bob says, "I'm at Adams Street." Well, Bob's connected to port number 6. So when Bob sends the response message back to thing 1, the switch says, "That's right, I remember that address." And it sends that packet from 6 to 1. And that's the only place it goes. It doesn't go out the rest of the ports. It goes directly to the switch that thing 1 is connected to, which is really pretty neat. It also means it reads all the packets that go through it. And then if it gets a packet from, let's say, thing 2, and it's never gotten a packet from thing 2 before, and thing 2 is asking for Susan, the switch says, I've never heard of Susan. I don't know where Susan is. So it's going to send that packet to every port it has. And it's going to take it in from thing 2, and it's going to send it out to everyone, saying, where's Susan? Anyone know? And then when Susan replies, it says, great, Susan's on 8. I know that now. So thing 2 and Susan, you can have your own conversations on 2 and 8. And it will actually route that packet from one port to the next without just sending it everywhere. So layer 3, the network layer. This is where it gets really fun. So when you link computers together, you create a network. When you link networks together, you create an internetwork. So at one point, somebody took the work off the end of it and decided, let's just call it the internet. You may have heard of that before. There's a lot of stuff that happens on layer 3, especially when you start linking networks together. It gets crazy. So the protocol that's used on the network layer is called TCP/IP, which is the Transmission Control Protocol / Internet Protocol. So there are 6 basic protocols inside of this protocol that operates on the network layer, layer 3. There's IP, or the Internet Protocol. There's ARP, the Address Resolution Protocol. ICMP, IGMP, TCP, and UDP. It's just a bunch of crazy stuff. It all does really cool things. If you want to learn more, you can send me an email. So this is TCP/IP. If you look, it looks kind of familiar, right? The application layer, the transport layer, the data layer, and the physical layer. So if you look, what's actually happening is the application, let's say Facebook, is putting its information inside of the TCP, or the Transmission Control Protocol, which lives on the network layer, the transport layer, with the user data, which is then being put into the data layer, or the internet, with a IP header that says, where am I going? Who am I talking to? Then goes onto a network interface, which is where the Ethernet protocol lives. And it's being added inside of an Ethernet header and an Ethernet trailer that says, where am I? Where have I been? And did I get there? Does that make sense? 4 layers. They're actually going inside of each other. And then makes a nice little packet, and that packet is sent along to talk to things. So have any of you heard of HTTP, or the Hypertext Transfer Protocol? It's what you put in front of every web address. If you don't put it, Google puts it for you, or Safari puts it in there for you. This is how your computer knows what web page it's talking to, and the web page knows what computer it's talking to. That's how when you go to Facebook, you don't see everyone else's browsing activity on Facebook. You see yours, because your computer is talking to Facebook. Facebook is talking back to your computer. Have you ever heard of like a data crash, or a website goes down because of too much traffic? It's because this one server is trying to talk to a whole bunch of computers all at the same time, and it gets overloaded, can't handle it, shuts down. That's what makes the internet work. It's really cool. But that's on the application layer. So is FTP, or the File Transfer Protocol. That's how you move like large files between here and there. Then the Simple Mail Transfer Protocol. That's how you get your emails. It's all on the application layer, which then gets put into the transport layer, then into the internet layer, then on the network interface, and it goes from computer to server and back and forth. So, how does your computer know what its address is? So it gets a MAC address when it's manufactured, and that's fixed to the computer for all time. But then on the network, in the IP header, it doesn't want to use that MAC address every time. It's too long. So it wants to use a shorter address called an IP address. So where does your computer get that? You've probably seen these before as 192.168.1.100. So the way to look at that is in subnets. So 192 is the first 3 blocks. It's like a large grouping. It's saying it's somewhere inside of this network that's at 192 is this computer I'm trying to talk to. It's huge, obviously. And then 168, it's like a whole neighborhood of homes. Inside of 192 is 168. And then even smaller, 101. And it's just on that street. And then finally, the last block is like the house address, 137. So the entire string for that home is 192.168.101.137. So that's how it talks to other devices on the network. Now, where does it get the address? That's the responsibility of the Dynamic Host Configuration Protocol, so known as DHCP. What DHCP does, so you can see there's like 4 steps. When you connect a cable or connect to a Wi-Fi network, your computer sends out a broadcast message, sends it out to everything on the network. And it says, where's the DHCP server? I'm new here. Can someone tell me what my address is? DHCP server gets that and says, oh, you want to talk to me? Puts its address at the end of the message, responds to the computer, and says, you can have 192.168.101.137. And then the client says, okay, great, I know who you are. Can you tell me that again? And the DHCP server says, you betcha, 192.168.101.137, that's your address. And then it makes a note of it in its table. And then forevermore, that computer is known as 192.168.101.137. There's also, so those are local addresses. Your 192.168.101.137. You may have seen if you try to get your external IP or your internet IP, it's something crazy like 34.187.295.104. And that's your external IP. So the organization that rules the internet has reserved certain addresses to be private IP addresses, certain addresses to be public IP addresses. So your private IP addresses are in 3 different blocks. And these are the only 3 that you'll ever see inside of an organization that's connected to the internet. Those start with 192, 172, and 10. So your computer will only ever have one of those 3 addresses if it's connected to a network that's connected to the internet. If your local network isn't connected to the wide area network, you can have whatever address you want. You can make it up because no one cares. But if you connect that to the internet, then you won't actually get any internet traffic because that address is probably already reserved for someone else or assigned to someone else. And so then their data traffic is already in all of the switches of the internet and all of the routers of the internet as having that address. So you will get all of their data traffic, or you won't get any at all, because when you connect to the internet, this server says, oh, I see you at this address. Wait a second, I already have that address. You can't be at that address. So it might just ignore you, and then you won't have the internet. So that's why it's important to only use one of the 3 blocks of IP addresses reserved for private use, 192, 172, or 10. The reason there's 3 is because they have decided how large your local network can be, and that's how you determine which of the 3 you will use. So the 192.168, you have to use both of those numbers, which means you can only have the last 2 numbers to come up with addresses for your local computers. And those last 2 numbers can only go up to 254. So you have 254 subnets, and each side of each subnet, there are 254 addresses. 254 times 254 is some big number. It's like 2,000 or something. Higher than that, I'm being told. Right. Anyway, the next number is 172.16, and then 2 more numbers. So there are a few more numbers in the third or the second address block, if you're coming from the left, like we do in America, that you can use. And then you have 254 over 254. So you have a few more addresses in that range. And then in the 10 range, all 3 of the last 3 numbers are available for you to use, which means you have tons and tons and tons of addresses that you can hand out to local computers. Now, have any of you ever seen an address that starts with 169.254? Usually is accompanied by a little yellow light. It means your computer can't connect to a network. So 169.254 are built into every computer in the network interface as self-assigned IPs. And your computer gets to make up the last 2 numbers, and it just picks them and assigns it to themselves. Because that means they can't contact a DHCP server. So it looks, if no one replies to its broadcast saying, where's the DHCP server, then the computer decides its own address, and it starts with 169.254. And then the last 2 numbers are made up. So if you ever see that address, it's probably say, your computer has a self-assigned address, 169.254. That means you didn't connect to the network. It's talking to itself. Neat. Do you have any questions at this point?
How often would it ask the postmaster for a new address in that scenario?
Great question. So in your DHCP server, you can set a lease time that determines how long the computer will get to keep that address. Even if the computer falls off the network, the DHCP server will hold that address for a certain amount of time. That can be anywhere from a matter of minutes to days. However, if it's days and you have lots of computers joining and disconnecting from your network all the time, each time a new computer connects, the DHCP server will hand them the next address in the pool. So on a specific subnet, you only have 254 of those. You might think that's a lot, but if you add up all the devices that can connect to a network, you run out pretty quick. So your computer, your phone, your tablet, I've got 3, I'm just one person. So that will multiply very quickly. And then if you forget the network on your computer, let's say you go in and you say, I don't want to connect to you anymore, forget the network, and then you reconnect to it, then this has 2 addresses in the DHCP server's table now. So I'm eating up addresses pretty quickly. And if I save those addresses for 7 days, and each time a new person connects to my network, it hands out a new address, I will run out of addresses really quickly. So the lease time is pretty important. It defaults to around 1 day or 24 hours, which is why if you think on your home network, your computer will typically get the same address, because as the lease expires, it frees up that address. If you connect your computer again, that address gets given back to your computer. But if you've got a bunch of different devices that are constantly connecting and disconnecting, that's why your computer will sometimes get a new address every couple days, because your DHCP server is releasing all those addresses and then handing them back out in whatever order it sees fit. Good question. Anyone else? Okay, great. Next, we're going to talk about configuring a router. So I'm going to close this PowerPoint presentation. Let's say that you buy a brand new router for your house and you want to configure it. First thing you're going to have to do is connect to it. So this router has been returned to defaults. It's like it's brand new. So by looking at the bottom of it, I can find out that its SSID, or Wi-Fi name, is Netgear 77. So I'm going to connect to it. Because I connected to it earlier, my computer memorized the password, but the password's also on the bottom of the unit. Netgear has decided that they're sick and tired of random strings of numbers and letters. So they make really cool passwords now. So the password for this one is fresh plum 115.
You can remember it and retype it in.
Yeah, they're really entertaining. So I'm going to go and change this right now. Anyway, so now my computer's connected to the interface. So I'm actually controlling this little black box through the interwebs. So the first thing I want to do is change the name of that wireless internet, because I don't want it to be Netgear 77. Because if I want my friends to connect to it, you guys saw, look at all these freaking addresses. There's Netgear 07, Netgear 10, Netgear 43, Netgear 77, a bunch of other random things. So I want to make it make sense. So I'm going to name it something that everyone can remember, and it's not a stupid name. This specific router is going to go back in an ATEM case, and it's number 3. So I'm going to name this ATEM03. Now, you may remember earlier when we were talking about wireless, that the wireless internet works on 2.4 gig and 5 gigahertz frequencies. So this specific router has 2 little radios inside of it, and they can't have the same name on this specific model. Some models you can give them the same name, and then your computer will figure out which network it wants to join, whether it's the 2G or the 5G. And then I'm going to change the password from fresh plum to that. I'm going to click apply. And it's going to take a minute, and it's going to think about it, and then you'll see my computer disconnect from the Wi-Fi network. So now you see the 2G radio just turned on as it's rebooting. And there's the 5G radio. Type in the password I just changed. And now I'm reconnected. Hooray. You'll see that this says error. There's no internet. However, I will probably never plug this in to the actual internet, because it's going to be a local area network only. So I want to make it stop giving me that error, because that's annoying. So I'm going to tell it to just use a static IP address, and I'm going to tell it to make up its default MAC address. And I'm just going to type in some DNS servers here. So DNS stands for Dynamic Name Service. Basically, what did I say? Oh, hush. Since each thing on the internet has an address that has 4 strings, like 34.181.172.89, if you wanted to go to Google, you would have to remember those 4 numbers for Google servers, and you would have to type those in every time if we didn't have DNS. That'd be really annoying. If you wanted to go to our website, avad3.com, you'd have to remember the 4 magic numbers that avad3.com is living on, which is silly. So they made these things called the Dynamic Name Service. And it takes avad3.com, and it says, when somebody types in avad3.com, I need to send them to this string of numbers. And it does that automatically in the background. There are a bunch of DNS servers that are around, and they all share a table of those names and addresses through the internet using the network layer. To talk to each other and to say, oh, I've got a new one, here's what it's called, here's what it is. When someone asks for this, send them there. So Google runs a couple of those. Those are at 8.8.8, and 8.8.4.4. We're back to this page. It's a wireless page. So if your computer ever asks for a DNS address, it should get it automatically, and it should be your local router, or the 192.168.1.1. Since the router connects to the internet, it gets that DNS table from the internet, applies it locally, and then your data traffic on your local network passes through it to go out to the internet. And it takes care of that, so you don't have to go anywhere else. But if for some reason your local thing can't handle it, or doesn't want to handle it, or you're having errors with it, you can send your DNS traffic to someone else's server by typing an address in. Let's see what else is in these menus. So the attached devices is really useful if you plug something in, like a thing, and you can't find out its IP address, but you want to control it. So this happens a lot in production. So like this thing has an IP address when I connect it to the network, but there's no way to find it through the front panel. So I can pull up my routers page and go to attached devices, and I can see who all is using my internets. So you can see that my computer is the only one connected, and because I'm using the DHCP that's built into this, it has given me an address of 192.168.1.2. The rest of this is, stuff you can do. Parental controls apparently aren't working. Netgear has a ready share thing, so you can plug in a USB stick to the back of the router, and it will show up as network storage, which is just a place that you can store things that's not directly tied to a real computer. So let's go into the advanced and mess with the DHCP settings. I'm going to go down here to setup, local area setup, and I'm going to say, I do want to use this router as a DHCP server, but I want to change the router's address itself from 1.1 to 0.1. And I want it to hand out addresses from 100 to 254. The reason we do this, this is an avad3 specialty setup, is we have lots of devices that have static IPs. So these are devices like this thing that don't tell you their IP address, but they want to have the same IP address every time. They will ignore the DHCP server, and they will just have an address. So those devices, if I let this router assign DHCP addresses from 0 to 100, which is where we have intentionally placed all of our static IPs, it would assign an IP twice, basically. So one of our ATEM switchers has an IP address of 192.168.0.20. If I connected 18 devices to this router, and then I connected my computer would get the address 192.168.0.20. If I then connected that ATEM, I would have a problem, because now there are two devices with the same address. So what we do, instead of, one way to fix this is to do reserved addresses, which you can do down here. But because we have like 80 some odd devices with static IPs, and we have tons of these, because each little device can travel with one of these so that it can create its own network. And then when we bring all that equipment together in one room, we have a master network. Because we would have to go to every single router and add an address reservation for every unit, we simply tell it, instead of starting your DHCP handouts at 2, start them at 100. That way, anything that's below 100 won't get double addressed. So that's just a little thing that we do to cheat here at avad3 to make our networks work. So I'm going to apply those settings, and it's going to think about it for a little bit. There's a bunch of other in-depth things. So one of the neat features of this specific doodad is I can turn off all of its router functions. So I can turn off the DHCP, the DNS, and its like control of the network, and I can make it just be a wireless access point, which means it takes the wired network and makes it wireless. This is really handy if you're like, if your router at your house is in your living room and you can't get signal in the bedroom. That happens to me. It's really annoying. So what you can do is take a cable from your router in your living room, run it up through the attic all the way to your bedroom, and plug one of these guys in and make it into access point mode, which as soon as this finishes, I'll show you. But if you just bought this from the store, changed the wireless name, and then plugged it into another router that was also doing the same thing, you would then have two networks creating an internetwork. And there would be some collision that happened there, because this one would see that there's another thing on the network already handing out addresses. And the addresses that it's handing out are 192.168.1.2 through 254. And it would see that and it would say, if this other thing is already handing out those addresses, that means I can't hand out those addresses. So it would move to 192.168.2, and it would start handing out addresses in that range. But because it's on a different subnet, the two things don't talk to each other automatically. So then you wouldn't have the internet on your second router, because it would be trying to talk to the internet through the other router. And the other router would be saying, I don't know who you are or what you're doing here, but you can't do that. And it would basically not let you connect. Come on. Oh, now I made it mad. Yep. Does that all make sense? I don't think this is going to let me do it. It's angered.
So when you get the pencil out and then do the hard reset, right?
Yeah.
Press and hold.
So here's the problem. I found it. I still have an old address. So you can see I changed the router's address to 192.168.0.1. My computer's address is 192.168.1.2, which means it's on a different subnet. Which means my computer, even though it still thinks it's getting network, can't connect to this because they're on different subnets. So what I'm going to do is I'm going to go in here and I'm going to tell it to renew my DHCP lease. This will give me a new address from the router in the 0 range. See, because I told it don't issue anything under 99, I got the first address available, which is 100. Now, it's going to ask me for the password, which you can find your default passwords on the bottom of the unit. So let's make it an access point. Netgear makes it really easy. They say, do you want it to be in access point mode? Check the box, and it'll tell you, here's what I'm going to do, and then here's what I'm going to turn off. So it's going to create a 2.4 gig wireless network. It's going to call it HMO32G with that password, and then it's going to create a 5G network with all that, and then it's going to say, you should probably turn off the network on your existing router. The reason it does that is it's going to assume you're going to put this thing on top of another thing. If you do that, you'll have two wireless devices sending out signal right on top of each other. The reason that's bad is it uses RF. RF is very finicky. So if I put a transmit antenna next to another transmit antenna, but they're on different frequencies, they're going to get in a giant fight, and neither one's going to win. So I'm going to decrease my total transmit range by half at least, sometimes more, based on the frequency separation. So it's saying if you already have a wireless network, you should turn it off. The exception to that is, if I'm using this as an access point and I want to extend my wireless network, I'm going to put it far away from my other router, which means they won't interfere anymore. So then I can ignore that. And then it's going to ask me for an IP address. And it's going to say get dynamically from the router or used a fixed IP address. So here's the thing. If I wanted to log back into this, so let's say I click apply and it connects to my other router, which I don't have, so I'm not actually going to click it because then it would freak out. It's going to get an IP address from DHCP. I don't know that address because the routers randomly decided what the address should be and assigned it to it. Let's say I wanted to turn off the access point mode and take it somewhere else and use it as another router. How would I get this address to log back into it?
You could use that page you talked about earlier where it tells you all the device addresses.
Brilliant. I would log into my other router, my first router, that was the home router, and I would go to its attached devices, and this would show up. And then I would know its IP address, and I could log into it, change the settings, just like I'm doing now. There's also a wireless repeating function on these. So what that means is I don't have to run a cable between the two. It will take the wireless from one thing and then send it back out. It's really handy. It doesn't always work that well. It takes a lot of fancy configuration to set up. And because it's wireless, it's not as stable as an actual cable. This thing can do a lot of other stuff. For example, port forwarding, which is how you get information that's traveling on the data layer from the data layer to the network layer to travel from router to router and then back down to the network layer where computers can see it. It's very confusing, I know. There's a lot of other fancy things with networks, such as VLANs or virtual LANs, which is where you can create networks that travel on one cable. It's very weird. You have to have specific equipment that can read a VLAN ID. They have specific routers that can create VLAN IDs. But those are useful. So let's say I want to create a guest network on a wireless access point. But I also want that wireless access point to be able to access my actual network. Say I want to connect with my phone to the access point and control something on my computer. But I want a guest who walks in to be able to connect to the internet on the access point, but not access my computer. I could use VLANs and run one cable to my access point and then separate my computer that's plugged into the network and the internet. So then the guest can get to the internet and I can get to my computer. That's a very basic explanation of VLANs. They do a lot more. They get a lot more complicated, super fancy. But that's basically what happens. Any questions? Network? So let's say in the production world that I wanted to connect to a device that had a static IP address, but I didn't have a router available, but I had a switch. How would I do that? Anyone know?
Can you say it again? Sorry.
So I have, let's say, a sound console. The sound console can only do a static IP address. That static IP address is, let's just say for fun, 192.168.0.38. I want to connect my computer to the console with cables, but I've only got a switch. I don't have a DHCP server. I don't have a router that can do a wireless thing, so I can plug my computer in here and the console in here, but how would I connect them? Because remember, it's on a different subnet. They can't talk to each other. The console has a 192.168.0 subnet. My computer, because it can't find a DHCP server, is going to give itself a 169.254 address.
You have to manually get in and hit all your settings.
Look at that. Exactly. So I would have to manually adjust my settings on my computer to be on the same subnet as my console. So to do that, it's pretty simple. We're going to pretend that I do have a wireless access point, but for some reason I'm not getting DHCP. So I can go in here and choose manually. Your console is going to have the same 3 boxes on it. It's going to say, where am I? What's the subnet mask? And where's the router? Now, the subnet mask does a really complicated thing with the IP address, and it basically says which part of this is the network ID and which part of it is my ID. So the subnet mask says each time there's a 255, it says that's part of the network that you're on. The 0 says this is your specific number. So if it's a different, if it's, let's say, a 10.0.100.100 address, and only the 10 is being used as the network ID because I've got so many computers on my network, I need the last 3 numbers to differentiate them all, then its subnet mask would be 255.0.0.0 because the 10 is saying you're on the network number 10, and these last 3 numbers are specific to that computer. So that's the subnet mask. So your console is going to say, what's my IP address, which part of that is mine, and which part of that is the network, and then where's the router, or where should I be looking to send all of my information to. Because I don't have one, I'm going to make up one for my computer on the same subnet as my console. I'm going to give it a random number. I'm going to say, just like on the console, the first 3 numbers are the network part, the last one is specific to the computer. And then because I don't have a router, I'm going to delete that field both on my computer and on the console. That's important. If one of them has a router address, it will look for it, but it won't ever be able to find it. So it will keep sending information to that address that doesn't ever exist, and it won't ever get to your computer. So if you erase it on both of them, then it will say, I guess there's not one. I will send all of my traffic to anywhere, and then they'll be able to talk to each other.
As long as the IP you assign is not the console.
Right.
It's the only thing you can screw up.
Yep. Yeah. If the console already has an IP, don't give your computer the same IP. That would make everything angry. Then you can click OK and click Apply, and it will be able to find the console, and they can talk to each other just through the switch with no DHCP or anything like that. So, any questions about that?
I've dealt with a lot of this stuff over the years, audio stuff, and usually if you have some kind of router on the front end of your system and it's handing out addresses, really just get them plugged into the same thing and they find each other and play nicely. So
Yep.
DHCP is amazing, but you know, if you're closed in your closed system with no outside access or nothing giving out addresses, you need to know where your stuff's at.
Right.
I imagine with all the stuff you guys do, mission critical.
Yeah, for sure. Because basically each rack that we have is kind of self-contained, and each Pelican that we have that carries a switcher in it is kind of self-contained. We would have to put a router in each rack for it to be self-contained and be able to connect a computer to it and then control what's inside of it. But that means when I take this rack and 5 other racks to the same show and I plug them all in, I'm going to have 5 networks that I need to connect to. So if I want to control this piece of gear, I've got to connect to this network, control this piece of gear, disconnect from this network, connect to the next network. It'd be a nightmare. So what we do is we have one router that is the king. And then when we bring them all together, we just don't plug any of these in. We unplug them. The big racks like this that usually travel with other racks don't even have routers in them. So if I wanted to, which we'll get to in the next segment, control this device, I would have to give my computer its own IP address. Does that make sense? Awesome. All right, that's all I got on network.